For nearly a century, it was the final word in our solar system. A dim, distant point of light discovered by a young astronomer in 1930. We called it Pluto, the king of the underworld. And for 76 years, that's all it was. A tiny, frozen, and fundamentally dead world, drifting in the eternal twilight of the Kuiper Belt. In 2006, NASA launched a probe, a mission called New Horizons, on a 9-year, 3 billion-mile journey to finally say hello. We sent a geologist to an ice ball. We had no idea what we would find. The expectation was a cold, inert, crater-pocked world, much like our own moon. But we were wrong. Now let's access the field logs and analyze the true nature of this incredible visitor. The journey was long. New Horizons slept for years, crossing the orbits of giants. It flew past Jupiter, using its gravity to slingshot toward the unknown. As the probe awoke in 2015, the first images began to filter back to Earth. At first, just a blurry dot, like the photos from Hubble, but then the dot gained features. It resolved into a world with a heart. The encounter on July 14, 2015 was not a simple flyby. It was a revelation. In a matter of hours, Pluto was transformed from a point of light into one of the most complex and geologically active bodies in our entire solar system. It was an impossible discovery. This tiny world, 4.5 billion years old, should have lost all its internal heat billions of years ago. It should have been frozen solid to its core. It should have been dead. But the very first high-resolution images told us this was false. It was alive. We saw a vast, bright, heart-shaped plain of nitrogen ice stretching over 1,000 kilometers wide. This region, Sputnik Planitia, was almost completely devoid of impact craters. That lack of craters means the surface is young. It's being resurfaced right now as we watch. This is not a dead world. This is a world where nitrogen ice flows like glaciers on Earth. We saw mountains, but not mountains of rock. We saw towering peaks rivaling the Rockies made of solid water ice. This water ice is so cold at minus 380 degrees Fahrenheit that it becomes the bedrock. These mountains of ice are floating on a vast, churning sea of softer, weaker nitrogen ice, like icebergs in a frozen ocean. This was the encounter. The moment that a tiny, distant object became a vibrant, complex, and baffling world. It was a world that defied our laws of planetary science. A world that had no right to be so active, so young, or so weird. This is the outsider. This is the world we demoted. In 2006, the same year New Horizons began its journey, Pluto was reclassified. It was demoted from planet to dwarf planet. The implication was that it was just one of many, a simple, inert piece of debris in the Kuiper Belt, a dead world. The New Horizons flyby was a direct, physical rebuttal to that idea. The data that came back didn't just add to our knowledge, it fundamentally challenged our definitions of what a world can be. This dwarf planet was found to be more geologically complex than Mars. Let's look at the evidence. First, the glaciers. The heart, Sputnik Planitia, is not solid ground. It's a deep basin filled with nitrogen, methane, and carbon monoxide ices, and it is actively churning. This massive sheet of soft ice is convecting just like a pot of boiling water, but with ice and over millions of years. Warm, buoyant plumes of nitrogen ice rise to the surface, cool, and then sink back down. This process, solid-state convection, renews the entire surface of the plane. We are looking at a surface that is, in some places, less than 10 million years old, a blink of an eye in geological time. This activity is driven by the faint residual heat from Pluto's rocky core, struggling to escape. Then, the atmosphere. Pluto has a thin blue, hazy atmosphere, rich in nitrogen. This atmosphere is not static, it is alive. As Pluto moves through its long 248-year orbit, the ices on its surface sublimate, turn from solid to gas, in the faint sunlight. This gas forms the atmosphere, which then freezes back onto the surface in the dark. This creates weather. It creates seasons. The data showed that this cycle is so powerful, it transports methane ice, creating vast fields of towering, blade-like spires of ice, some as tall as skyscrapers. This is not the behavior of a simple, dead rock. This is the complex meteorology of a dynamic world. The discovery was not just of a new landscape, it was the discovery of an active, breathing outsider that refuses to fit our neat and tidy boxes. Pluto's geology is not the geology of a dwarf. It is the geology of a planet. This is not like the others. When we see geological activity in the solar system, we have a cheat sheet. We look for one of two things: proximity to the sun or proximity to a giant planet. The Earth is active because it's large and has a molten core, a relic of its hot formation. Mars is mostly dead, a frozen desert because it's smaller and lost its internal heat. And then we have the icy moons, like Europa and Enceladus. They are active with geysers and hidden oceans, but they are not alone. They are kept warm by a constant, brutal, gravitational tug-of-war with their giant parent planets, Jupiter and Saturn. This tidal heating flexes the moons like a squash ball, generating friction and heat, keeping their interiors liquid. Pluto has none of these things. It is tiny, smaller than our own moon. It is far from the sun, receiving only a whisper of its warmth. And it has no giant planet to knead its core. Its only large companion, Charon, is in a stable tidal lock, providing no significant tidal heat today. So why is it alive? This is where the comparisons become alien. Look at this glacier. Here on Earth, a glacier is a river of water ice, carving a valley out of rock. On Pluto, the valley itself is made of water ice, which at minus 380 degrees is the rock. The glacier flowing through it is made of frozen nitrogen. It's a river of solid air, carving a landscape of frozen water. Think about that. Now look at the mountains. We see peaks, the Tenzing Montes, that are 4 miles high, as tall as the Canadian Rockies. But they aren't rock, they are mountains of pure water ice. They are, in effect, giant icebergs. They are floating in the sea of nitrogen ice that makes up Sputnik Planitia. They have been pushed to the edges of the convecting cells, like foam gathering at the edge of a boiling pot. This is not like the others. Mars has vast, dusty plains and giant, dead volcanoes. Earth has tectonic plates and rolling oceans of liquid water. Pluto has a continent-sized lava lamp of exotic ices, pushing mountains of frozen water around a landscape that is constantly, impossibly, renewing itself. And this isn't even the weirdest part. When we looked closer, at the terrain adjacent to the Great Heart, we found something that has no right to be there. A terrain so bizarre, it looks like a snakeskin, or the scales of a dragon. These are the bladed terrain, or penitents, fields of methane ice, frozen into towering, knife-like ridges, hundreds of feet tall. They are formed by the slow sublimation of ice in the faint sunlight. This is not just a discovery, it's a paradox. A world that should be the simplest, most cratered, and most boring body in our solar system is instead the most geologically diverse and visually stunning. It's an outsider, alone in the dark, that found a way to make its own heat and forge its own destiny. This is the weirdness. The glaciers of nitrogen are incredible. The mountains of water ice are astonishing. But they are only symptoms. They are the surface expression of a much deeper, much stranger, and far more profound mystery. The real question: where is the heat coming from? This is the central paradox of Pluto. It is a small world. It has no giant moon to flex its interior. According to the laws of thermodynamics, its small rocky core should have cooled and frozen solid billions of years ago. It should be a block of ice and rock with no energy left to do anything. And yet, we see a young surface. We see active convection. This is a flagrant violation of our expectations. It means there is an energy source, a heat engine, that we did not account for. To find it, we must look at the impossible data. Anomaly. Number 1, the volcanoes. When scientists analyzed the images, they found something just south of the Great Heart, a massive, sprawling mountain, 150 kilometers wide and 4 kilometers high. It's called Right Mons. It has a deep, central depression, exactly like a volcano's caldera. Nearby, there is another, Picard Mons, that is even larger. These are not volcanoes of molten rock. These are cryovolcanoes, ice volcanoes, and they are enormous. Their volume is comparable to some of the largest volcanoes on Earth, like Mauna Loa. But instead of spewing hot lava, they have erupted a thick, slushy, viscous flow of something. A mix of water, ammonia, and other ices. This is not a surface feature. This is a plumbing system. This is a direct pipeline from a warm, active interior, venting to the surface in the recent geological past. This discovery proved Pluto had an interior warm enough to move material, but it didn't explain the source of that warmth. That answer came from the heart itself. Anomaly number 2, the missing gravity. Sputnik Planitia, the heart, is a giant impact basin. It's a colossal hole in Pluto's water ice crust, likely punched by a Kuiper Belt object billions of years ago. A giant hole, a basin, should have less mass than the surrounding terrain. When New Horizons flew over it, it should have registered a negative gravity anomaly. It did not. It registered a positive gravity anomaly. There is more mass concentrated in that basin than in the surrounding highlands. This was the weirdness that broke the case wide open. There is only one way to explain this. The hole must be plugged. It must be filled from below with a material that is denser than the ice crust it replaced. And there is only one candidate, a vast, hidden, subsurface ocean of liquid water. The models were clear. The impact that created Sputnik Planitia cracked the ice shell, weakening it. The liquid water ocean from below, being denser than the ice, pushed up against that thin crust, bulging into the space. Later, the nitrogen ices filled the basin from above. We are looking at an ocean 60 to 100 miles deep, sloshing beneath a 100-mile thick shell of ice, just waiting for a crack to reveal itself. A liquid water ocean. How can it possibly stay liquid? The answer is twofold. First, Pluto's rocky core, while small, is still generating heat from the decay of radioactive elements, just like Earth's. Second, the ice shell above it is one of the greatest insulators in the solar system. It traps that faint heat, keeping the ocean from freezing. And the ocean itself likely has help. Scientists believe it is not pure water. It is a salty brine, rich in ammonia. Ammonia acts as a natural antifreeze, lowering the freezing point of water by dozens of degrees. This is the engine. This warm, insulated, antifreeze-laced ocean is the heart of Pluto's activity. It's the heat from this ocean that escapes through the thin crust of Sputnik Planitia, driving the convection of the nitrogen glaciers above. It's this ocean that provides the slush for the cryovolcanoes. This is the ultimate weirdness, the tiny, demoted, frozen dwarf in the dark. Is an ocean world. This is the new data. The New Horizons flyby was a single, fleeting moment in 2015, but in 2025, an even more powerful eye turned toward the underworld. The James Webb Space Telescope, JWST's infrared vision, gave us something New Horizons could not: a long-term look. It confirmed that Pluto is not just a place, but a climate. The new data revealed that the complex haze of nitrogen and methane isn't just a side effect, it controls Pluto's atmosphere. Webb's observations confirmed that this haze is the primary engine of Pluto's atmospheric heating and cooling, a new kind of climate unique in our solar system. But this new data, combined with a decade of reanalyzing the New Horizons data, all points back to the ocean. The great engine below, the latest models, published in 2024, have analyzed the cracks and bulges in the ice over Sputnik Planitia. They have used these features to calculate the very nature of the ocean itself. The findings are precise. The ocean is likely 40 to 80 kilometers thick, and it is salty. The data suggests Pluto's ocean is about 8% denser than seawater on Earth, a salinity comparable to Utah's Great Salt Lake. This salt, this ammonia-rich brine, is the key. It is the antifreeze that has allowed this ocean to persist for billions of years, trapped in the dark. This is the encounter, not with a dead rock, but with a new class of world. Pluto is the prototype. The profound implication is that Pluto is not an exception, but the rule. The Kuiper Belt, once thought to be a graveyard of frozen dead comets, is now a suspected realm of ocean worlds. If Pluto can do it, then other large dwarf planets, Eris, Makemake, Haumea, could also be hiding these vast, ancient liquid water oceans. This discovery transforms our search for life. It suggests that the habitable zone isn't just a narrow band around a star where water is liquid on the surface. It's anywhere you can trap heat. It could be in the dark, under shells of ice, in worlds we've never even seen. Pluto has been a messenger. It has shown us that the solar system is more creative, more complex, and more alive than we ever dreamed. It has forced us to abandon our old, simple definitions and to embrace the weird, the impossible, and the unknown. This tiny, distant king of the underworld has, in its own way, given us back the solar system.